Hi, Assalamualaikum. We are from Group 8 and my name is Shahrul, ALIAH, FARISYAH, BINTI, HALIM. And the other members is NURUL, AZURA, RECHER, EGOH and Shahrul, Nizam. So today I will be presenting about the introduction. So for introduction, there are project background. So for the project background for this project, we'll be presenting the fundamental concept of power flow analysis and the analysis of power system networks up to 30 buses, and we also concentrate towards the development of MATLAB coding of the Newton-Raphson method power flow analysis. So next is problem statement. So the problem statement for this project is the increasing demand of electricity has pushed electricity output to near capacity level. And the burning of fuels and gases produces pollution that can create health issues. Next is natural resources are finite and will run out in a matter of days. Next is objectives. So for the objective of this project are as follows, which are to analyze the impact of different load level in a 30 buses power system, to obtain the highest load incremental value before the system collapse, to install the accurate amount of power of PVDG or photovoltaic distribution generation in power system, to study the effectiveness of PVDG installation in 30 buses power system. Lastly, project scope. The scope of the project is the MATLAB coding editor ready to simulate IEEE 30 buses Newton-Raphson load flow analysis. Next is the variable that will be controlled in the MATLAB Newton-Raphson code is the real and reactive power of the load. The variable that will be used to install the PVDG in MATLAB Newton-Raphson code is the real power of the generation. Next is the location of the PVDG installation will be on bus 7 with the power wattage of 500 megawatt. And lastly is the power system also contains of 41
Hello, my name is Shahrul
transmission lines
SABRIE,
with
metric
24
number DE
branches, which
2098.
are 6 to
So for
9,
today,
6 to 10, 4 to
present
12,
to you about the
and 28
literature
to
review.
47.
For the first one
That's
is
all
the
from
power
me.
system control and
We will
stability.
continue the presentation
It
to
is
the
by
next
PM
slide.
Anderson and Fuad from IEE Power Engineering Society have studied about the classical stability of 9-bus system. The classical model of a synchronous machine may be used to study the stability of power system for a period of time. And the second one is computer techniques in power system analysis. It is by MF High and Diman Chatterjee from McGraw-Hill Education have provided some information related to IEE bus, 14 bus, 30 bus and 57 bus power system. This is out of the data sample are in the following format. The third one is the prediction of voltage collapse in electric power systems by Azah Mohammed and Gulf Jasmine from journal Kejuruteraan 8 1996 have investigated that several load flow solutions are obtained by increasing the PQ loads until load flow diverge. On top of that, these studies also contribute the 4-bus and 24 system data such as bus data and line data, which help in better understanding by IEE standard power system. That is all from me. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is NURUL AZURA binti Abdul Halim. My metric number is DE 2088 and I'll be presenting for methodology and simulation for this group project. First of all, I wanted to show you that this is our 30 bus IEE standard power system that we use in this simulation. It contains one slack bus, 5 PV bus, and the rest of it 24 PQ bus, and it contains 41 transmission line. And this is our bus data that we use during the simulation soon. If you want to know details, you can refer to our project report. And then this is our line data. Okay, so for simulation, our group decided to use MATLAB as the software for the simulation. The bus that we will manipulate the data of the load is bus 7. Let me show you the simulation of the initial condition. After I run this simulation, it will pop up the result here. This we can compare to the table that we put in the report, and then we change it to 200% of the original data, which is 68.4 and 32.7. Then we run. We will get that the simulation is still working. It means that the system is still in a good condition. And then we rise the load to 400% of the original data, which is 114.0 and 54.5. And then we run again the simulation. We still get the reading, which means the system is still in a good condition. And let me show you the system, how the system is collapsed. When I increase the reading to 1620%, which is 392.16, and this one is 187.48. Okay, let's run the simulation. And you can see this is the error that come up after we change the data. And then after the system collapse, in order to avoid it from collapsing at 1620% of the load, we install the PVDG, which we will add the real power here in bus 7, because PVDG, photovoltaic, only produce power in real power. So I will increase it to 166% of the, which is 500 megawatt, and we will run the simulation, and you can see that we still get the data, which means the system is in a good condition back. Well, I think that's all for simulation.
Hello, my name is RECHER REPAI DE200117. So I'm going to present to you the conclusions for our group project. So this is the summary of project. So for the first one, the importance of power flow studies is necessary as part of planning the future expansion of power system, as well as in determinations the best operation in existing power systems. Other than that, the principal information obtained from the calculations of power flow study is the magnitude of voltage and phase angle of power losses at each bus section, and the real and reactive power flowing in each line in power system. Newton-Raphson method is suitable for analyzing the load flow of the bus systems, and the voltage, magnitude and angles of a bus system were observed for different values of load power. Then the incremental percentage of load power also observed until the system collapsed, and the findings have been presented in this report. And from the analysis observation, it is concluded that the increasing load power resulted in decreasing of voltage magnitude, thus system collapse, and installations of high generation power of PVDG can overcome the problem. So the next one is the recommendations throughout the group project that we already do. So for the first one is that Newton-Raphson method is one of the suitable yet efficient in solving the load flow of the bus systems, and it is more accurate with insensitive to factors like bus selection, regulating transformers, and the number of iterations required in this method is almost independent of the system size. However, it has some limitations. Newton-Raphson method is difficult to determine the abnormal operating solution, And as we all can see in the power flow equation, there are multiple solutions which are normal and abnormal solutions. Since there is any extra loading imposed on the system beyond the limit, it can lead to the collapse of voltage, and the estimation of steady state operating limit is very important. Somehow these limitations can be overcome, and we recommend to use the proposed floating number, which we can call it as GA, which is the genetic algorithms representation. So this GA optimization process is almost insensitive to the initial settings of the solution variable, and it also has the ability to determine the multiple power solutions compared to the Newton-Raphson method, which are able to give accurate value for the normal solutions only. That's all from me. Thank you.